Dante Certification Level 2, 2nd Edition. Unicast, Multicast, and Broadcast, and Dante Flows. Unicast, Multicast, and Broadcast are three different ways of transmitting data across the network. Now, when Dante sends media across the network, we can only send it by unicast or multicast. We don't send it by broadcast. But broadcast is used for things like DHCP requests, ARP requests, and things like that. So let's just cover them all, and we'll get this part well understood. In this chapter, we'll also talk about IGMP snooping, which is a way of managing your multicast traffic. And we'll close with a section on Dante Flows, which is basically how Dante manages its resources, ensuring you don't oversubscribe the processors. So let's start with unicast transmission. Unicast is, again, like sending a letter with the post office. I put the envelope in the mailbox, and it's sent to that person. Now, unicast is great when I want to send unique information to one destination. But what happens when I want to send the same information to multiple destinations? Well, if I'm sending the same information to multiple locations with unicast, I have to duplicate those transmissions over and over again. It's like sending party invitations where I'm going to drop multiple envelopes in the mailbox. Now, in this example, you can see I'm putting a strain on the transmitter. Eventually, that would run out of bandwidth, right? Well, not only that, but if I have multiple switches, it would put additional bandwidth on the trunk lines. The data in triplicate is being sent across this link. Now, unicast is great for one-to-one communication. And even when I'm splitting signals, there might be times when I'm going to choose unicast. We'll talk about that later in the chapter. But if I'm trying to do a truly massive distribution, there might be better ways to do this. So let's compare this with broadcast. So in a postal analogy, broadcast messages are kind of like junk mail. I'm going to hit everybody in a postal code, and each person can go through the messages they receive and decide if these apply to them or not. When the broadcast message is sent to the first switch, that switch will send it out to all ports. Of course, one of those links goes to another network switch, and that device will send it out all of its ports as well. Now, you'll notice that the broadcast message does not cross the router, and that's good. That means when your computer at home sends out a DHCP request, it stops at the edge of your home. It doesn't go out across the internet to every system in the world. Now, when we're sending large messages, the problem with broadcast is that it goes to every device on the network. Most likely, that means a lot of devices are getting data that they don't want, and we could quickly overwhelm the port speed of those devices. So generally speaking, broadcast is used as a method of locating other devices on the network, not as a means of constant communication. And a DHCP request is a great example of that. When I'm joining the network, I don't know where the DHCP server is, so I send that request as a broadcast message. But, of course, when I'm a Dante device and I'm transmitting my content to other devices on the network, well, I know where they are, so there's better alternatives for us to use. Multicast transmissions aim to split the difference between unicast and multicast. Think of it like a magazine subscription. Devices that are interested in a particular stream will subscribe to it. The switch makes a note of that and coordinates with the other switches to build the distribution list. Now, when the data for that transmission is sent, the switches can look at their distribution lists. The first switch realizes it only needs to send the stream to the second switch, and that second switch knows exactly which devices wanted that stream. So, with multicast, the transmitter only had to send this data once, and the only devices that received it are the ones that wanted it. Now, it's worth knowing that the multicast stream IDs look like IP addresses. It doesn't mean that your device suddenly changed to a new IP range. These are just numbers that you would tune into just like you would tune into a radio station or a television station. And it's also worth noting that Dante does not require you to manage the IP addresses. The only reason why we go over this is if you're on an enterprise network and the IT manager asks you, hey, which multicast subscriptions are you using? Now you'll know what they're talking about. And of course, we'll show you how to find the particular streams that we use. So the multicast streams fall in the range of 224.anything through 239.anything. Now multicast, as we showed it to you, assumes that a function like IGMP snooping is engaged on your switch. Most switches will default with IGMP snooping off. So if your switch doesn't support IGMP snooping, or if it's not engaged, then it will do the best it can in a backwards compatible way. It will send that multicast traffic to every port in your broadcast domain, or in your VLAN. So this is what multicast distribution looks like without IGMP snooping, and this is what multicast distribution looks like with IGMP snooping. So the more multicast traffic you have on your network, the more likely you are to use IGMP snooping. When configuring IGMP snooping, you probably want to turn it on all switches. However, there is a feature called the IGMP querier. The IGMP querier will be the device that keeps the master list of where all of the multicast subscriptions go. So, you'll want all switches to have IGMP snooping engaged, but only one of them would be the IGMP querier. Finally, it's helpful to know that IGMP snooping comes in multiple versions. Dante devices support IGMP snooping version 2 or version 3. So, if you're on a network that has the latest, you're in great shape. If you're sharing a network with another system that only supports IGMP snooping version 2, no problem, we can accommodate that as well. Okay, so Dante can send audio or video media as unicast or multicast. In our system, we have two icons. The dot with the arrow indicates unicast, meaning you're transmitting to one device. Multicast has an icon with a dot and a forked arrow, indicating that the network can split that signal for you. Now this will become more important when you progress to level 3, but it's worth noting that unicast traffic can cross a router to other networks. It targets an IP address and it's routable. We would call that a layer 3 connection. However, multicast is limited in scope. It will not cross the router. Its distribution is limited to the broadcast domain in which it sits. And in fact, if we look at the diagrams I drew earlier, you'll notice that unicast crossed the router, while multicast did not. Another benefit to unicast is that it can achieve lower latency than multicast. Unicast packets have the address of the intended recipient right on it. As a result, it can traverse the switch more quickly. Multicast arrives with a subscription number. The switch then needs to look that number up, figure out who wants that packet, possibly duplicating the signal for each path it must take. Now all of this extra work can start taxing your CPU in your switch. So we design our multicast packets so it's less burden for the switch to move through, and of course we allow more time for it to get across the network. If you're ever concerned about how much load your switch is taking on, know that managed switches will often offer a chart showing the CPU load. Now just to give you an idea of how much multicast traffic your switch can move, let's talk about an installation at a late night talk show. This system went up in 2012 and it was completely built around Dante. They had about 150 inputs on stage, completely distributed by multicast to 9 different destinations. They used an affordable small and medium business switch, and the CPU load was only about 20%. So there was capacity to grow. So in summary, we learned that unicast is a one-to-one communication method. It offers the best latency performance and is the easiest for your network to move, even across a layer 3 space. Multicast is a great way to do massive splits on the network, managing bandwidth by splitting the signal in the switch, rather than at the transmitter. When using massive amounts of multicast, IGMP snooping may be a good choice to ensure multicast only goes to the devices that ask for it. When you set it up, you'll probably want to engage IGMP snooping on all switches, but remember, only one of them should be the IGMP querier. Okay, with a basic understanding of unicast and multicast, now we can explain Dante flows. Back in the Level 1 class, in the Audio Basics chapter, we mentioned that sending data across a network isn't just about the size of the data you need to move. There is also the network overhead to get it there. And we compared this to a shipping company. A shipping company is not interested in the size and the weight of the object that you're interested in transporting. They need to know the size and the weight of the entire carton, with all the packing material and everything. Now for video, these differences don't impact us much because video signals are pretty large. A network packet's maximum size is about 1.5 kilobit. A single frame of video is much larger than that, So we obviously have to break a single frame into pieces and send that across the network. When we make a Dante video flow, a single video stream will occupy the flow all by itself. But audio data is much smaller. The core overhead of a network packet is about 40 bytes. And of course we have to add other data, like a timestamp, so we know when this plays out. If we only sent one 24-bit digital word in the network packet, well, that's only 3 bytes of data. Compared to the 40 bytes in the header plus timestamps and everything, that's certainly less than 10% of the bandwidth being used to move audio. That seems horribly inefficient. I think we've all had the experience when we order something small from an online retailer, like, say, an SD card, and yet it comes in this huge box. We stand there in disbelief, thinking there's got to be a better way. So when we send audio across the network, we group channels together. Now this is similar to buying a AA battery. You'll probably find it difficult to go to the store and buy just one. They'll start around a 4-pack. And that's the way it'll work with audio as well. When you send an audio stream by Unicast, it's automatically set up with 4 channels. So let's suppose I've got this DSP, and it's going to send signal to 2 different amplifiers. One of them is 4 channels wide, the other is 8. The moment I subscribe one channel, a 4-channel stream is established. The channel I requested is loaded in, and the others are sent as blank. As I subscribe more channels from the DSP to the amplifier, they will simply fill the unused channels in this stream. Now, once I get to the 5th channel, we're out of space, right? So we'll establish another 4-channel stream with 1 channel in it. And if you keep going, you'll fill up the unused channels in that stream as well. When I want to transmit to the 2nd amplifier, I have to create another flow. When I make my first subscription, the device establishes a 4-channel flow. The first channel is populated, the rest are blank. And as I create the other subscriptions, they fill in the unused slots. Now Unicast is the default behavior. However, if these 2 amplifiers were receiving the same signals, we could change this to multicast. When we send channels by multicast, we can bundle audio in an 8-channel stream. And of course, once I've transmitted these signals as multicast, it can go to as many destinations as I want. And interestingly, you could look at that 4-channel amplifier and say, well, wait a minute, I only need 4 channels here. The channels it's looking for are in that 8-channel stream. It will pick the channels it needs and ignore the rest. Now, while it's always nice to see the explanation this way, let's actually put it to use. Let's give you a demonstration of unicast and multicast flows on the network, and we'll see if that sheds some light for you. Here I have a system where you'll see most of my devices are gigabit, but there are a few 100 megabit devices at the top. As usual, Dante established 1 clock leader, and if I go to the Network Status tab, we can see that nothing is transmitting or receiving right now. The less than 1 megabit per second is as low as our system can display. Really, that traffic represents the overhead of discovery, clocking, control reporting, and things like that. Okay, so let's go to the Routing tab, and we'll focus on the stage box and the first mixer. I'll also open the device view for the stage box so we can check in on the flow count. Here, we can see that this is not using any of its 32 flows currently. As soon as I make my first subscription, we'll see the stage box is sending about 5 to 6 megabits of data to the mixer. And if we look at the flows used, we'll see there is now 1 unicast flow. Nothing too surprising, right? Okay, let's go back and create 3 more subscriptions between these same 2 devices. So now we have 4 channels going from the stage box to the mixer. We can see that there's no change in bandwidth. It's the same 5 to 6 megabits that we had before. And if we look at the stage box, we see there are no more flows being used. So again, when we send a unicast stream, it's automatically set as a 4-channel flow, whether you're using 1 or all 4 channels. Okay, so we've got 1 unicast flow running right now. Let's subscribe a 5th channel. Indeed, if we look at our bandwidth, we see an additional 5 to 6 megabits for the additional flow, climbing to about 11 to 12 megabits per second. If we look in the flow counter, we indeed see that a second flow has begun. Okay, I think we get the idea here. So let's take bigger steps. Let's subscribe all 16 channels from this stage box. Of course, 16 channels divided by 4 channels per flow, that means we need 4 flows. And of course, we're only going to one destination right now. Let's see what happens as we create subscriptions for additional devices. Let's send these same 16 channels to the monitor desk. Since this is Unicast, we're going to have to send this twice. We can see our bandwidth climbs to 48 megabits per second, about 24 megabits to each receiver. And of course, we see our flow count go up. We're using 8 flows in total, 4 to each receiver. Okay, once more for good measure, let's send this to a digital audio workstation for recording as well. Again, we see our bandwidth go up on the transmitter as we use more flows. Now, the good news is that Unicast only goes from the transmitter to the destination. It doesn't hit anybody else on this network. Now, Unicast is great when I want to send different signals to different locations. But in this example, I'm sending the exact same signals to 3 different destinations. Now, I might still decide to do this by Unicast, perhaps to achieve lower latency. But just for the example, let's flip this to Multicast and see what the difference would be. At the bottom of Dante Controller, we'll see a reading that tells us how much multicast we're sending cumulatively. Now, this is just an estimate based on the subscriptions we've created. If I look in the Transmitter tab, there is a section that will show us how many multicast flows we have going at a time. Right now, we have none. In the tool ribbon, you'll see the icon for multicast, the dot with the forked arrow indicating we are splitting the signal on the network. Click on that, and we can choose the channels that we want to send in a multicast flow. Remember, we can have up to 8 channels in a single flow. In this case, I'll just choose the first 8 channels from the stage box and click Create. Now, we can see a list of channels that we've grouped together in a multicast feed. So at this point, if somebody was to ask for channels 1 through 8, they would receive the multicast flow. If they ask for 9 through 16, they'll get those by Unicast. Okay, for this example, let's get channels 9 through 16 so they are also transmitting multicast. And indeed, we see those channels listed here as a second multicast flow. If we look at our bandwidth used, we see we're only using 21 megabits per second to send those 16 channels to 3 destinations. When it was sent by Unicast, this was around 72 megabits per second, so this reduces the load on the transmitter significantly. Indeed, we can see we're still reaching the 3 devices we wanted to reach, no problem there. However, look up and down this list. We'll see that everyone is receiving this traffic. Now, what does that tell you? Well, that probably tells you IGMP snooping is not engaged yet, because multicast traffic is going everywhere. Now, if this was all the multicast traffic we had, we could have a discussion about should IGMP snooping be engaged or not. It might not really matter one way or the other. But before I turn on IGMP snooping, let me take us out to the breaking point, and we'll see the difference that it would make. Up here, I have a Dante AV transmitter. This is receiving a signal from a camera that is pointed at my set here. Right now, we can see this is not transmitting to anyone. No devices have requested this subscription yet. If I look at the flow count for this video device, we'll see it keeps track separately of flows for video, audio, and control. Let's suppose I know I want to send this video feed to multiple destinations. Flipping this to multicast can give us a significant bandwidth advantage. To make the multicast subscription, again, I click on the multicast icon, select the video channel, and click Create. Now watch what happens to the bandwidth on the devices. I can see the device is starting to transmit 103 megabits. Now remember, no video receivers have subscribed to this image yet, and yet we're transmitting it. Well, remember, a multicast transmitter doesn't know who's supposed to receive a specific signal. It just transmits, puts a multicast subscription ID on it, and trusts the switch to get it to the destination. So even with no one asking for the subscription, the multicast transmitter started putting out this 103 megabit stream. Since we don't have IGMP snooping engaged yet, you can see the traffic is going to all devices on the network. The devices at the bottom are 1 gigabit, so they're able to manage this traffic no problem. But look at the 3 devices at the top that are only 100 megabit devices. We are overwhelming them beyond their capacity. All right, so let's turn on IGMP snooping and show you how that helps. For expediency, I've already made the other settings for IGMP snooping on other pages. You can see the Managed Switch tutorial for suggestions on that. At this point, all I need to use is these master on-off controls. Once I engage IGMP snooping in an IGMP querier, watch the bandwidth statistics in Dante Controller. You'll see the improvement made with traffic management. Now, it's safe to say that some switches might take a few minutes for this to take effect. Others will be faster, like what we're seeing here. At this point, I can see the 21 megabits of traffic from the stage box is only going to the devices who have asked for it. The 103 megabit video flow has not been requested by any devices, so it holds fast at the switch. And of course, the devices not involved with multicast traffic are not bothered at all. Okay, it's time for a little extra credit. I'll show you some shortcuts that will help you with massive subscription lists, as well as converting multiple channels to multicast at the same time. First, let's suppose that we want to send the inputs from the second stage box to the mixers and the digital audio workstation. When we wanted to route this before, we were able to establish a diagonal route in the main routing screen. But you'll notice it can't continue for the second stage box that way. I mean, if I come to the top, I'll get a diagonal route, but it will overwrite the patches from the first stage box. We need these channels to start the diagonal route from channel 1 to 17, 2 to 18, and so on. I could click at each intersection one at a time, but there is a simpler way. Let's go to the receiver's device view in the Receiving tab. In the left column, we have all the receiving channels. On the right, we have all the transmitters on the network. We can select the range of channels we wish to assign and simply drag them over. If you look in the routing grid to the right, you'll see these subscriptions reflected. Now, I'll do it again for the monitor mixer, then once more for the front of house console. Okay, now remember, by default, these are all going to be sent by Unicast. We want them all to be sent by Multicast. Well, when I go to the Multicast assignment pop-up, if you want to assign all channels, just click the box at the top. When you hit Create, Dante Controller will automatically break them into 8-channel groups for you. And sure enough, as we look at the bandwidth, we can tell that the multicast streams are taking effect. All right, so that was a functional example of Unicast, Multicast, and Dante flows. But what happens if we exceed a device's capacity for flows? Well, let me reset here, and I'll show you an example of a device with one of our Ultimo chipsets. Those only have 2 flows in it, so we'll show you how to get a larger distribution out of that. So here I have a device that is a lectern microphone input. To keep this affordable, they used our Ultimo chipset, which only has 2 audio flows. So, if I make a subscription to the first mixer, we know I've used 1 Unicast flow. When I make a subscription to the second mixer, I've used a second Unicast flow. So what happens when I try to make a subscription to the third device? Oh, I don't get my green check mark. Just like we learned in level 1, let's hover over this symbol to get the tooltip and find out what's wrong. Of course, we know what it's going to say, no more flows. Of course, we can see I'm getting the 2 subscriptions we made earlier, we just can't get to this third one. So how do we solve this? Of course, we do it with a multicast flow. At that point, we'll be able to hit as many devices as we like within our broadcast domain using a single multicast flow. Okay, so we go to the device view for the lectern mic input, we click on the multicast icon in the tool ribbon, and we make a multicast feed with that single channel. We now see the multicast stream here, and off to the right, we can see that the system is able to reach all 3 destinations. No problem. By the way, if you ever need to delete a multicast flow, all you do is highlight the flow you want to remove and click delete. The system will give you a warning telling you that your signal will be interrupted as you convert it from multicast back to Unicast, but click through that and you'll be all set. So, hopefully that was a decent introduction to 3 different ways to transmit data across the network: Unicast, Multicast, and Broadcast. We talked about IGMP snooping as a way to manage your multicast traffic on the network. And we talked about Dante flows and how that prevents you from oversubscribing any of your devices.